Bonjour tout le monde. Welcome back, everybody. Thanks for tuning in to this lecture number 2, online lecture number 2. And I hope you like the first one. It's kind of, I guess, a bit of a twist on the way we teach in class, but it's the same idea. Essentially, I'm going to go through the problem one step at a time. It's the problem from the book, and hopefully you were able to follow along. So this next one, we're going to do problem 1025 in the text, 1025. Also from chapter 10, of course, statistical process control. We're talking about COMM 225, and of course it's Peter Rosenthal here. So I hope that you're enjoying your spring break, and hopefully you're having a good rest. So before we get started, here is of course a picture of me lecturing. Hopefully it's not too much of a boring lecture, but just wanted to remind you that of course it is Peter Rosenthal who is giving this online lecture for COMM 225. Okay, so let's get started. We are talking about statistical process control here, and I wanted to just do a little refresher here. If you take a look at the text, page 330, page 330, there's a table there. It's the same table we looked at last problem, but just a bit of a refresher, a reminder, we're going to use this table. It's a very nice and simple way to compute your upper control limits and lower control limits. And remember, what we have here is the sample size. So this is the sample size depending on what it is. It shows us which factors to use for our X bar charts and our R charts, X bar charts and R charts. So for example, if our sample size, just as a refresher here, was let's say 10, I'll just point to the 10. Okay, 10. Then it allows us to determine what the factors are that we use in the formulas. For example, in this case, it would be 0.31. And for the R charts, 0.22, 1.78 for the lower control limits and upper control limits, respectively. So just an example, very straightforward way to get the factors you need in the formulas, which we'll see in a minute. Okay, tout le monde. So let's take a look at the problem. So this is problem 1025 in the text, also posted on Moodle. So it's available there for Moodle, on Moodle if you wanted to download that. And let's take a look at it. So the problem is a small manufacturer of metal ring seals for aircraft engines has been asked by its major customer to implement SPC. That's statistical process control, similar to SQC, statistical quality control. One major type of ring requires cutting a 1/8 inch wide slot using a milling machine. The following 6 samples of 5 observations each, taken every half hour, are the width of the slots in inch made by the milling machine on the ring. So what all of this detail is really saying, after all is said and done, is that we have 6 samples. So the first very important thing that I'd like to point out is the difference between number of samples, in this case we have 6 samples, and the sample size. So if you take a look at the sample size, each one of the samples, we have 6 samples, the sample size is 5. There's 5 items in each sample. Okay, tout le monde? And this is important because when we use that chart on chart 10.2, table 10.2 on page 330, we need to know the sample size. The sample size is 5. Sample size is also known as N. So N is sample size. I'll just jot that down here. Sample size. Okay, tout le monde? We need that to calculate our upper control limits and lower control limits. Okay, so to give us the data, part A, set up the sample mean and range control charts for this operation. Is the process in control? So we know how to do that. We're going to create the charts, we're going to calculate upper control limits, lower control limits, and we're going to plot the X bars. Remember we did it last question. And we're also going to do the same thing for the range. And then part B, what they're asking for is, let's say there is a 7th sample. So imagine there's a 7th sample here. They give us the data for what's in the 7th sample. Using those control charts, is the process still under control? So we're going to do those calculations next. Just one more point that's, I think, very important here is that, remember, last class we talked about 2 different kinds of data. There's the attribute kind of data and variable data. And the variable data is just like this. Variable data is data that can vary, such as 0.1253, 0.1254, etc., like we see here. And for this kind of data, we calculate the X bar in our charts. The attribute data, which we're going to do in next problem, that's for like a P chart, is things like yes or no, right or wrong, fail or pass. This is the kind of attribute data versus the variable data where you actually have a number and the number varies, let's say, with certain decimal points or things of that nature. Okay, so just to clarify, this is variable data. So with variable data, we do X bar and R charts. This tells us what kind of chart to use. Okay, so let's take a look at the solution for this problem, which I worked out here, and we'll walk together. So the first part, as usual, I just sort of rewrote over here in this section the problem information. So this is what's given in the problem. We have our 6 samples here. There's our 6 samples, and we have a sample size of 5. So this is the exact same data, just to keep in mind the difference between sample size of 5, so it's n equals 5, and the number of samples, which is 6. Okay, so now that we have that, the first thing we want to do is we want to calculate our X bar right here, one for each sample, and we want to calculate a range, one for each sample. So just like the last problem, the X bar is nothing more than the average of these items. So we take the average value, so we add them up, divide by 5, and we get this number here. And we do the same thing for each of the samples. Do the same thing for each of the samples, and that's how we get our X bar for each sample. And what we're going to do, in fact, is when we do our charts, when we create our charts, we plot the X bars. And then the next thing we do is we get the average of all the X bars, and that's our X bar bar. So it's the mean of the means, and we're going to plot that on our chart as well. Then we have our range. The range, if you recall, is the maximum value minus the minimum value. So what you do is you find the highest number that we have here, the highest number, we subtract it from the lowest number, and that's how we get our range. The highest number in the list minus the lowest number, that's our range. And then the R bar is the average of those ranges. So we just take all of these numbers here, we take the average value of that, which is divided by 6, and we get our range, R bar. Okay, tout le monde? Next step is we want to calculate our upper control limits and lower control limits for the charts, for those charts. So that's done right here. Okay, for example, here's our formulas. Recall the formula right here. And what I'm going to do is I'm going to use the formula using table 10.2. And in case you have an exam situation, by all means, unless they specify calculate the standard deviation, or if they give you the standard deviation, then of course you should use it and use those formulas. But if they don't, then automatically use the chart. The chart will be given in the exam, and usually it's a very straightforward, easy way to get the factors, these factors here that we're looking for. So as a refresher, I'll just go back to the chart here. I'll just go back to this chart. And in this case, our sample size is, of course, 5. Sample size, number of observations in the sample is 5. So just like last problem, it turns out to be 5. And A2, right there, factor for A2 is 0.58. So if we go back here, there's our 0.58 right there, which is used for both the upper control limit and the lower control limit. And these values here is the range right here. That's the range that we calculated before, right there. There's our range that we calculated, so that's our R bar. And then we just do the math and we multiply the two numbers and we get the upper control limit and the lower control limit, which we're going to plot on the chart. We're going to plot on the chart. Similarly, for the range chart, so here's the formulas for the upper control limit and the lower control limit for the range. And if we go back to our chart here, let's just take a look at that. Okay, in this case, for a sample size 5, the upper control limit is 2.11, the lower control limit is 0. So that's how we get our values. And then we can move back here. There's our, I'll just remove that. There's our upper control limit, our lower control limit, and we get our values to plot on the chart. Okay, tout le monde? Hopefully that seems straightforward. Let's take a look at the charts. We'll spend a minute on that. So I did plot that as well. First of all, what we have here is the X bar chart, the X bar chart. So the three important things that we want to draw on the chart is the upper control limit, very important, and we should put a line such as this to kind of show what the upper control limit is. Lower control limit, which is right here. And in fact, I realized that I did not label it, but I should have. I should have labeled it right here. And it's also good to identify, in fact, you should identify the X bar bar, which is the center line. So there's the X bar bar, which I've identified right here. Why? Because we want to see how does our X bars, which are these items, how do the X bars behave? Do they look random? And therefore we need to know what the center line is to see if they're sort of above and below in a semi-random way. So I'll just clear that off. And of course, where did we get this information? This information is nothing more than the X bars. So if we just go back here, we'll see, for example, this point over here is this point over here. So 0.1251 and 0.1252 are plotted right here. So we just plot our X bars, and as we can see from this chart, the process looks like it's nicely in control. So everything is random enough, and we don't see anything which is out of the limits, beyond these limits. If anything showed up beyond the limits, that would be out of control. Okay, tout le monde? So similarly for the range charts, what we want to do is we want to plot our lower control, which is 0 in this case. Okay, it's right here, we want to show that. We plot the upper control limit, which is 0.005275, right here. And we also want to show over here the center line, which is R bar. So we should actually plot that too, right there. R bar is 0.0025. Okay, just backing up, you can see from there. So we want to plot that too, and these are the R's. So we're just plotting the ranges. So for example, looking back at our problem, 0.0016, 0.0023, and if we look at our points here, here it is. So we're plotting it close enough. It doesn't have to be perfect tout le monde. If you're doing a problem in an exam, for example, the most important thing are these limits, to plot these limits, and the R bar as well. And then as best as you can, just sort of plot your R's. Doesn't have to be perfect, but it's just enough to show, is there anything outside the limit? Or is there anything which is showing some kind of non-random behavior? Okay, tout le monde, so that's it. That's what it takes to actually draw your charts. I'll just clear that off. There's one more question. I'll just go back here to the problem. And the problem said B. So let's take a look at this. There's one more part to it. The seventh sample contains the following values. So they give you another 5 values here. Using the control charts that we just plotted, is the process still in control? So given these data, okay, it's almost like having a 7th sample here. So we need to compute a new X bar, which is the average, and we need to compute a new range, which would be the range for this sample right here. And I did that right here. So if you do the math, the X bar I get is 0.12648, 0.12648. So let's check our chart. 0.12648 falls somewhere around there. 0.12468 falls somewhere around there. So we're nicely within, not a problem. And if you look at the range, 0.0055, 0.0055, okay, I mark here it's out of range, and let's just double check that, 0.0055, okay, and indeed 0.0055 is somewhere here, so this is now out of range, out of control. That is the conclusion, it is out of control. Okay, so that answers the question. Is the process still in control? The answer is no. The answer is no, it is not still in control. Okay, tout le monde, so that's our problem 1025. I hope that was okay and was clear enough for you. If you have any questions, by all means, my email address is shown here. Send me an email and I'll respond to you as soon as possible. And if we need to, we can arrange a call. That's it for now, and see you in the next video. Thanks.